Today I'm going to be trying to make a pair of dividing calipers out of a high carbon railroad spike. I've done a bunch of railroad spike projects in the past, like making scissors and a clamp, but I think the dividing calipers will be a fun challenge. I'm going to be heating up the railroad spike throughout this process with my induction forge, which is an electronic way to heat metal, and I made a whole video about it, which you can find on my channel. I'm going to start by reducing down the head of the railroad spike, and my plan here is to use kind of both sides of the railroad spike for different applications. One to sort of be the ears that will fold over the other side of the dividing calipers, and the other to sort of be the male part versus the female ears. Now, the first thing I have to do after I'm done with the head is break the railroad spike in two, because I'm going to attempt to make this pair of calipers out of just one spike. So I put a line in the spike with a punch, and then I went over to my cutoff tool and I broke the piece in half, and then I can start to reduce down the other end. Now you can see these pieces are pretty small, but because with forging you don't lose a lot of material, I'm going to be able to draw them out and make them into a really long pair of calipers, and I'm going to be able to get all the material I need out of just these two small chunks. Now I'm isolating down sort of what's going to be the head of the caliper, and then once that's flat, I can start to draw out the arm, kind of the leg and pointed part of the caliper. Now I'm switching between some rounded faced hammers and some flat hammers in order to draw this out very carefully and precisely. I want to leave all the hammer marks in this, so I want it to look nice and clean. I don't want to have any big dents or defects, and you can see the way that material gets drawn out almost across the whole face of my anvil. With one of those done, I can go ahead and grab the other side and I can do the same thing. Basically just hammering this to move the metal out of its way and taper it down in basically an octagon shape. I'm being, like I said, very conscious of my hammer blows, trying to make sure that I don't leave any dents by hitting with the side of the hammer, and draw this piece out as long as the other one so that the two sides match. Now it's super efficient to heat this up with the induction forge. It only takes a couple seconds between heats, and I'm not heating up the entire thing, which could lead to more deformation. You'll notice that the head that I'm holding in my tongs is never getting hot, because I'm actually keeping this in the tongs and just heating up the sort of shank that I'm drawing out when I'm using the induction forge. Now I've got both of those pieces kind of rough forged out to the shape that I want. I can continue to refine the pivot area by flattening out the male section, and then I'm going to be working on splitting the female section so it can wrap around that other kind of tab. Now there's a lot of different designs for dividing calipers, and these are just sort of one that I popped kind of in my head. I didn't do any real preliminary drawing. I did look at a couple of pictures of my friends Cliff Dufton and Ben Snure, who have both made really beautiful dividing calipers that are far nicer than these, and I used that as inspiration and kind of try to figure my way through this. Blacksmithing is not something that I'm very good at, and I'm basically just trying to learn by doing challenging projects and allowing myself to not get bogged down with the education side of it, which I feel like can happen, at least for me. Sometimes I'll get so wrapped up in reading about a process that I never actually do it, and then when I go to do it, there's so much information in my head that I feel like I stumble. With blacksmithing, I like to just sort of work my way through a process and figure it out how I think it should go. And then if I learn a more efficient way in the future, that's good too. Now I'm trying to make this pocket as clean as I can, so I take a piece of 1/4-inch steel, and then I just basically round over the edge on my grinder and then try to use it as basically like a cold chisel to make everything line up and make everything nice and flat and square. There's a natural sort of taper that happens when you hammer on stuff, so that inside pocket is a little bit tapered, but I'm getting it better. Every little hammer blow helps, and you can see now I've developed like a pretty nice clean pocket, and you can kind of understand the way these two parts are going to interact with one another. I had to do a little bit of tweaking on sort of the neck here to make sure that they would close to basically a 0 point, but so far the two pieces are coming out close enough, and the shape is basically what I want them to be, and so is the length. Now I let them cool down, and then I do a little bit of templating here. So basically what I do is I take some stencil material, some kind of cardstock, and then I trace out both legs. Now I need to put a pivot point in here, and because it's not an overlapping lap joint and it's like a pocketed joint, almost like a mortise and tenon, I have to be a lot more conscious of the way that these pieces interact with one another when they're going to pivot. Obviously, there's a shoulder inside the female section, and I have to worry about the male piece hitting into it and not allowing the piece to open up all the way. So I cut up these templates and then basically gives me a guide for what I'm going to need to do to the metal. And once it's done to the metal, it's done for good. Now I'm using my swivel jaw vise to hold this tapered piece, and then I'm just grabbing a little battery-operated Dremel tool and using a Carbide Burr. This is a Pferd tungsten carbide burr, which makes quick work of this metal and helps me clean out those hard-to-reach places way faster than a file would. Now from here, I'm just basically making some marks and some lines to try and guide myself into the grinding and cutting of these pieces. I'm very nervous about ruining all this work by making one cut too big, so I want to make sure that I'm being cautious and careful with everything that I do. I move over to another vise, another swivel jaw vise actually, so that I can have a little more of a sturdy workpiece. And then I go at this thing with a file to try to clean up the insides of those ears and then also clean up the face of the male section. I'm using this awesome welder's file from Pferd. It takes material off really easily and it's really, really long. It's like 15 inches long, so you have a lot of control when you're using it. I'll put a link down in the description of where you can grab one. I'm also using a file cleaner because you are going to get some latent metal inside any file, and having a good file card can really be helpful to clean that stuff out. Now that I've done a little bit of tuning, I want to drill the holes, but undersized holes, so that I can start to understand how this piece is going to pivot. So I'm starting with just an 1/8 inch drill bit, and I'm going to be drilling some 1/8 inch holes in this so that I can put an 1/8 inch metal pin in there, and I can start to understand the way this pivot's going to work. Now I'm very specific in using an 1/8 inch versus the overall 1/4 inch that I'm going to be using as the final pivot, because if I need to reposition this hole, I can do so without actually having to make the hole into like an oval. I can work my way up and kind of do my tuning and adjusting, and then if I need to eventually get up to that 1/4 inch hole, I can get there and I don't have to worry that these things might be in the wrong spot. And I had that exact experience happen on this, because as I drill through the two leaves, my drill went completely crooked and it was really terrible. It looked horrible on the backside, so I wind up having to go back in with a carbide burr and kind of grind that back out. But since nothing on this is square and flat, using the drill press doesn't really work, and I'm basically just doing this all by eye. Now I think traditionally, if you were going to really make a pair of dividing calipers from a blacksmith's perspective, you would have punched those holes, but there was no way I was going to get away with that. Here you can see how crooked that hole is, and you can see how I'm trying to correct it using the carbide burr, and it actually worked really well. Those carbide burrs really just burn through material. It's amazing. I did a whole video about them, and you definitely should check that out on my channel too. So now I chased out those holes to 3/16, which just kind of gets me a little bit closer. And then I'm going to use a 3/16 pin to kind of do those adjustments as well. And then eventually step up to the 1/4 inch. Now more tuning with the carbide burr, just trying to make that pocket as clean as I possibly can. And then I can go ahead and make some spacers out of this bronze. Now I wasn't going to make spacers at first, but I couldn't get the tolerance close enough. So I grabbed this bronze out of my scrap drawer. This is from an Online Metals proto box. And then I went over to my little lathe and just basically made some really thin spacers of a couple different thicknesses using the cutoff tool. Now these bronze spacers are going to wear pretty well, and then I can kind of flatten them out on some 400 grit sandpaper and insert them before I put in a 1/4 inch screw. I'm starting to get the feel for how this thing is going to look, but it still needs a lot of adjusting. So I'm using the edge of this file, which does have a cutting face on it, not a safe edge, to kind of clean up the inside of that pocket, and then just continue to clean up these leaves as best I can. You can see the way the swivel jaw vise I'm using really excels. A little more tweaking on the male section, and then I can go ahead and draw out the actual points on each of these caliper reins. So I want these to be a forged point that I'll eventually grind, but I left them dull before I did all this work because I wasn't sure how they were going to look and how long they were going to be. So now that I kind of have this pivot all figured out, I can draw them out. And I'm using really light and intentional hammer blows here to try to clean up the forging as best I can, not going to a super, super high heat, and just trying to flatten things out so that they meet perfectly in the center and then taper down to a nice piece in the front. There was a little bit of slag that popped off there, but luckily it was on the inside, and it kind of adds to the forged look, so I'm not mad about it. You can see the two pieces coming together and get an idea of what this thing is going to look like. I put the pin back in because I need to now straighten the reins because they're not actually touching on the bottom. So I heat up about the center of the calipers, and then I just lightly tap the two pieces together, which is going to help me get that really nice indexed look where the 2 points at the bottom meet exactly at the apex. Now I can do a little bit of grinding to flatten out the insides and round over the outsides of these 2 points. It helps to have a sacrificial pin in there. I'm just using a 1/4-inch bolt, but don't worry, we're going to make something nice and custom that's going to look really pretty. And I can clean up the outside of the pivot as well. As these things are starting to come together, I'm really excited how they look. The next thing I want to do is normalize and soften that female section and clean it with a wire brush. So when I put a bolt on it, it actually has the ability to pinch down and grab the other ring of the caliper. So now I'm over on my lathe with a piece of 1-inch brass stock, and I'm going to be making a custom thumb screw and a custom nut for this whole thing. Now I'm using my geometric die head to cut a 1/4-20 thread in there, and then I go ahead and use a knurling tool to knurl a pattern in the edge of this thumb screw. Now I wasn't sure what I was going to do for hardware here, but I decided that since I have a lathe and I have the material, I might as well make something pretty that'll kind of complement this whole thing and kind of gives a cool contrast between the forged look and then a machined look. Now there's my custom screw. Now I have to make the custom nut. I drill out with a number 7 drill bit and then take a 1/4-20 tap and tap this before I go ahead and take the knurling tool again and add some knurling to it and also cut it off, part it off. So now I'm going to have a perfectly matching screw and nut that when you have it on here is going to really complement that curved edge, and I just think it looks nice. I love a nice knurled pattern on a piece of brass. I always think it looks sexy, and I did a pretty light cut on this, which I think came out really nice. I just have to tune up the machining marks and grind those down a little bit over on the belt grinder, and then you can see it installed inside the caliper. The next thing I do before I final assemble is I go over to the wire wheel and I give this a pretty heavy wire wheeling, which is going to take any of the Leighton forge scale off of there and make these things shiny and look really beautiful. And then I just have to grind off whatever is left of that bolt on the pivot that was hanging out a little bit long. And stay tuned for the reveal. This piece came out so good. I'm super happy with it. You can see the forge marks in the calipers and they open and close really, really nicely. And then when you want to lock them in place, you just screw down that thumb screw. I'm super happy with this. This was a really challenging build. You can see the way you can use these. You can basically measure and divide with them, or you can use them as a scribe. Since these are high carbon, you can actually get a nice scribe mark on metal. Last but not least, I have to add my touch mark, which unfortunately sent these beautiful things flying across the shop. Don't worry, nothing got damaged, but you can see my little Z touch mark in there, which matches the rest of the forge stuff I've done. Overall, really challenging project, very fun. I learned a lot. Check out my other railroad spike projects on my channel. Thank you for watching, and I'll see you on the next video.